Review 4B, extra problems. Starts with factoring problems. It says factor each completely. So the big thing about this is being able to identify what type of problem it is. If you go back and look at the flow chart that's available on Schoology if you want to, you first have to ask yourself if there's a GCF. So look at problem number 1. It looks weird. It looks like there's going to be a GCF, but if you look at it, no, there's not. There's no GCF. So the next question says how many terms? How many terms? And there are 2 terms. So you go to the next box and it says is this difference of squares? And it turns out it is difference of squares, and you recognize that because you should know the square root of 25 and the square root of 16. This factor is kind of like an easy trinomial, but square root of 25r squared is 5r, and square root of 16 is 4. One of them is a plus and one of them is a minus. That's factor. Number two, I don't see a GCF. It has 3 terms, and a is equal to 1, so that's an easy trinomial. Easy trinomial, you say, give me 2 numbers that multiply to 20, and add it to 9. Looks like it's going to be 4 and 5. Multiply to positive 20, but add it to negative means both of those numbers are negative. This factors into n minus 4 and n minus 5. Notice there's no equal sign, so I don't have to find what n equals. I'm just finished there, that's fact. Next problem, is there a GCF? Well, yeah, there is. Both of those terms have an n in it. Don't forget to look for a GCF. That's a very common mistake. People forget all about that. If you take out an n, think about it as reverse distributive property. N times n would give me n squared, plus n times 2 would give me 2n. There we go, that's fact. Factors means written as a multiplication problem. And it's done. Next problem, when you've got 4 terms, that should make you think about grouping. Is there a GCF? No. How many terms? 4. Factor by grouping. That's what we're going to do. Okay, so we're going to put parentheses around here, and we're going to do that probably by grouping. So here is one group, here is the second. You do a GCF on each of the 2 groups. So when I look at the first group, both of them are divisible by 5 and an x squared. If you divide that out or reverse distribute, you'd be left with an x plus 3. Now you look at your second group and there's nothing in common, so other than 1. So we're just going to say the GCF there is 1, and if we take out a 1 and divide by 1, we still have x plus 3. But that's big because we want that to be a match. When we see that match, that's good. We write that match down, x plus 3. So imagine if you took that out or divided that out, you'd have 5x squared plus 1 left over. Now that is factored. Number 5, looks like there's going to be a GCF because of that 2, but these 3 numbers don't have anything in common, so it's not a GCF. It's a hard trinomial. So we factor a hard trinomial, kind of like an easy trinomial. We need numbers that multiply to 15. But they're not going to add up to 13 because of that 2. You have to think about the distributive property. Whatever number goes here is getting multiplied by 2. So we have to try to figure out how to multiply one of them by 2, and then they'll add up to 13. And so this is the way. 2 times 5 is 10, plus 3 is 13. That's going to be the way. I have to put the 5 in the spot that's getting multiplied by 2. I put the 3 over here. That's factored. So then the next one, it's the same type of problem. This is also a hard trinomial. It's always harder with negatives. But we need 2 numbers that multiply to 8. Negative 8, and that tells me that one of the numbers is negative. Those numbers are going to, they're not going to add up to negative 3, but that's because this number right here is getting multiplied by 5. So you have to figure out how to multiply by 5, and then they'll add or subtract and make 3. So how can we do that? This. If I did 5 times 1 minus 8, that's going to do it. All right, so put the 1 in the position that's getting multiplied by the 5, that's a positive 1, and then that's a minus 8 over there, right? That's going to give me 5x minus 8x is negative 3x. Then we have a problem set that talks about solving. Okay, and we could solve by, in this chapter we factor, we complete the square, we use quadratic formula, but we also isolate the variable. We like isolating the variable, and that happens when there's only one variable. If there's only one variable, isolate it. Otherwise, use any of those 3 methods. Number 7 looks like a problem that has already been factored. Notice the equals 0, that's important. We're looking for a solution, and a solution is going to be a number that makes a true statement. In this case, it's pretty easy to see. If you look at this, you're looking for what makes this expression equal 0. Well, that's easy to do in your head. That's negative 2. Negative 2 plus 2 equals 0. That's one of your solutions. Most people have a harder time with this one because it's harder to do in your head, but we're still looking for what makes this equal 0. The way I always do it in my head is it's always the opposite of that last number, but you also are going to have to isolate the variable, so you're going to end up having to divide by 5. That one is negative 2/5. So, to prove it, basically what we're doing is saying, what's going to make that equal 0? You subtract the 2 and divide by 5. You get the negative 2/5. So those right there are your 2 zeros, your 2 solutions. Next problem, number 8. That looks like an easy trinomial to me. I'm going to factor that if I can. 2 numbers that multiply to 2 and add up to 3. 1 and 2, of course. Multiply to a positive, add up to a negative. That means both numbers are negative, minus 1, minus 2. That's factored, but because of that equals, we have to find the zeros. 1 and 2. Next problem, number 9. Remember, when we try to factor, we're always asking ourselves if there's a GCF. This problem has a GCF. It's hard for it to recognize, but my key is when it looks weird, look for a GCF. These two both have an A, and so if I reverse distribute that, I'd have A minus 2. I am solving, so you still have to find the zeros. Most people are pretty good at this one by now. 2. 2 minus 2 is 0. Most people are a little bit weak at this one, and they think about it too hard. People will say like negative 1 or something, but that doesn't make 0. We're looking for the number that makes it equal 0, and so quit thinking so much, it's just 0. Number 10, most people are going to jump right in and say this looks like a hard trinomial, but remember, ask yourself if there's a GCF. And sure enough, there is. Okay, all 3 of those numbers are divisible by 5, so I'm going to reverse distribute that out of the problem. Now, I'm not finished, but at least I've reduced it from a hard trinomial down to an easy trinomial, and that's going to be easier for me to solve. Or factor. 2 numbers multiply to 5 and add it to 6. There's only one possibility. It has to be plus 1 and plus 5. Now, we still have that factor of 5 in the front, but if you think about it, we're looking for the numbers that make this thing equal 0. There's no way to make that equal 0, so I don't really have to look at it. I only have to look at the variables. And this 0 would be negative 1, and this 0 would be negative 5. Those are my solutions. And zeros. Number 11. Number 11 looks different. It looks weird. So you might be thinking GCF, but pay attention to the number of variables. This one only has one variable, and when that happens, we should be able to just isolate it. So I'm going to isolate this variable. Subtract the 6. 8r squared equals negative 80. We're going to divide by 8. R squared equals negative 10. We're going to square root both sides. You have to do a plus or minus. That's one thing you have to remember. When you square root both sides, you take plus or minus. That's going to give me r equals plus or minus square root of 10 with an I on it. Remember, square root of a negative is going to be imaginary. So just put an I there. Number 12 is the same type of problem. Let's subtract 4, 3b squared equals negative 48. And divide by 3. So b squared equals negative 16. Square root both sides, plus or minus. And b is going to be equal. I know the square root of 16 is 4. So don't forget about the ones that you know. The square root of negative is going to be imaginary. That's plus or minus 4i. So keep in mind what that means. It means your answers are 4i and negative 4i. We say plus or minus. Number 13 looks like a hard trinomial. Okay, a hard trinomial. So let's give this a shot. 5x and x. We need numbers to multiply to 6. Multiplies to positive 6, but adds it to negative, so that means that both numbers are negative. They're not going to add up to negative 17, and that's because one of the numbers is getting multiplied by 5, this one specifically. So we have to try to figure out how to make that work. 5 times 3 is 15, now getting close. That'll be 5 times negative 3 is negative 15, and negative 2 makes negative 17. That's it. That's the way. So I'm going to put the minus 3 in the position that's getting multiplied by the 5. I put the minus 2 elsewhere. Now, that is not finished. All I've done is factor. Now I have to solve or find the zeros. Most people are good at this one. It's 3. Most people aren't as good at this one, but just take the opposite of the black number, 2, and divide by that red number. 2. 14 also looks like a hard trinomial. So multiply by 5, actually negative 5, so that means one of the two numbers is negative. One number would have to get multiplied by 3, and then they'll add up to 2. Yeah, we can do this. That's going to be 3 minus 5. 3 minus 5 is negative 2. That'll be it. So we put the 1 in the position that's getting multiplied by 3. We put the minus 5 elsewhere. Solving, this 0 is going to be negative 1. This one is going to be positive 5 over 3. Number 15. 15 looks like an easy trinomial. And so you're going to start going like this. But the problem is, I don't know about 59. I don't know very many factors of 59. It might not be worth my time to try to factor it because I don't know what these numbers are. Okay? And also, it might not even be possible. So when it's not possible, that's where you're completing the square and your quadratic formula come in. So I'm not even going to worry about trying to factor this one. I'm just going to go to completing the square. Completing the square is going to be pretty easy if this is a 1 and this is an even number. Otherwise, like this one over here, I'm not doing completing the square. I'll just do quadratic formula now. But anyway, remember completing the square, we want to add this 59 over. R squared minus 12R. We want this blank space here equals 59 after we added that over. Okay? So what do we do with the blank space? We take half of that negative 12 and get negative 6, and we square it. Negative 6 times itself is positive 36. That will always be a positive number. Negative times negative is positive. That's positive. Okay? So a couple of things. If I take this expression on the left side and factor it, it factors into r minus 6 squared. R minus 6 times r minus 6. That's when we complete the square. But notice we added 36 out of nowhere. We have to add 36 to the other side just to keep that thing in balance. 59 plus 36, that would be 65, 95. Okay, 95. And now I've got an equation with only one variable. If you've got an equation with only one variable, you can isolate. So let's get rid of the squared. We're going to square root plus or minus. R minus 6 equals plus or minus square root of 95. Now, if you could reduce that easily, I would do that. But when it's something tough that I don't know, I might just get my calculator. Okay. So we're still isolating. Let's add 6. And at that point, you're going to see R equals 6 plus or minus square root of 95. So on that calculator, let's do 6 plus square root of 95 and 6 minus square root of 95. And those are approximately our two answers. Let's say 15.75 and negative 3.75. Yeah. So number 16, I'm not going to do completed square. 5 makes it too hard. I will use the quadratic formula there. Negative b plus or minus square root b squared minus 4ac all over 2a. So we've got an a number, a b number, and a c number right here. We just plug this in. All right, so opposite of negative 8 plus or minus square root b squared, that's negative 8 squared, that's 64. Go ahead and do that in your head, but that's always going to be a positive right there. Minus 4 times a is 5 times c is 2. All over 2 times a is 5. What I like to do is go inside the square root right there. 64 minus 4 times 5 times 2 gives me 24. So inside my square root there, right there, is 24. I'm looking at 8 plus or minus square root of 24 over 10. The square root of 24, we can simplify that because we know square root of 24 has a 4 in it. Square root of 4 is 2. So square root of 24 simplifies to 2 radical 6. So we have 8 plus or minus 2 radical 6 all over 10. And we can cancel. I call it b canceling, but you'd have to be able to cancel all 3 of those numbers. All 3 of those numbers are divisible by 2. So if you divide them all by 2, you would see 4 plus or minus square root of 6 over 5. And leave it like that. Or if you wanted to plug it in on a calculator, you could do that as well. I would go back here, and maybe 8 plus square root of 24 over 10, or 8 minus square root of 24. So then really the last two are going to be more of the same. We're just doing quadratic formula. Opposite, b plus or minus square root, this will be a. B squared is 1 minus 4 times a times c all over 2 times a. Calculator. 1 minus 4 times 9 times negative 14. 505. Okay? So that's a weird one. We've got negative 1 plus or minus square root of 5 over 5 all over, that's times a. So at this point, I don't care to rationalize or reduce down the 505. I would just get the calculator out here. I would split it, and I would say either we're going to add that square root or we're going to subtract it. So if I add negative 1 plus square root of 505 is this, but then don't forget, everybody always forgets to divide by 18. Don't forget. 1.19. So 1.19 about. And then if I subtract, that's when I subtract the square root of 505. Negative 1 minus square root of 5 over 5. You have to divide by 18. Negative 1.30. Approximately. Next one, number 18, same thing. I'd keep it rolling with quadratic formula. Your A and your B numbers are both 1, so opposite of B plus or minus square root of B squared minus 4 times your A number times your C number, all over 2 times your A number. I can do this under my head. That's 8, so 1 minus 8 is negative 7. So this is going to turn into negative 1 plus or minus square root of negative 7. 1 minus 8 is negative 7, all over 2. Okay, well, there's not much we can do with that, but we do know the square root of a negative is I. So this one's going to be imaginary. Let's just call that negative 1 plus or minus square root of 7 with an I on it over 2.